we're actually going to conduct a little experiment here, and we have a result. So, step one of the experiment is that you're going to have two containers of the same amount of water, and you're going to add the salt to one of them. So you can do that.
Wait, no, Shelby.
And now you're going to mix it thoroughly.
What is that?
This like mimics the waves of the ocean, which is one of the reasons why also ocean water doesn't freeze. Okay, so now that you're done mixing, you have one container of just regular water and one container of salt water. Now, what you do is you put this in the freezer. You can leave it overnight for it to freeze, and when you get up in the morning, you should have. I did my experiment in bottles, something like this, where you have your salt water in liquid form, and you should have your regular water in ice form. Now, does anyone know why the regular water flows and the salt water didn't? Well, in a molecular in a molecular level, water is always made of H2O, and salt, well, table salt is NaCl, sodium chloride. Now, what the sodium chloride does is it goes into the water molecules, and it actually prevents them from bonding. So water bonds with hydrogen bonds to each other, and what the salt does, it prevents those bonds from forming, so that's why it doesn't form a crystal ice. So it stays in liquid form. Now what this also does is lowers the temperature, the freezing temperature of the water. So instead of this freezing at 0 degrees Celsius, the same as this, it actually 26 degrees below Celsius. So you have to go negative 26 degrees Celsius, which is a lot higher in Fahrenheit. So salt water can freeze, but at a much, much lower temperature, which is, like Mr. Mali was asking, why are glaciers? Well, the reason why is glaciers are found in the poles, and the poles are much, much colder than the rest of the world, and glacier water has lots of less salt than regular ocean water does, so it's more like fresh water, and that's why it doesn't freeze.
That's cool.
Another reason why ocean water doesn't freeze is because ocean water is always moving. There's waves, and those waves cause friction, and that friction prevents it from freezing. So if you would keep mixing this some salt water, it wouldn't ever freeze because of friction. Now if you let it sit and you cool it enough, it will eventually freeze. Same reason why if you mix regular water, it won't freeze until you stop mixing it. So those are the two main reasons why ocean water does not freeze.
What causes the waves?
That's wind and lunar activity.
Gravitational pull of the
Yeah,
moon.
lunar activity. Now I think Amanda's going to do her PowerPoint.
Do you guys see that experiment?
Tell us what
So
you have
if you
learned.
increase the concentration of salt in the water, that it will never freeze?
It would freeze, but again, it would have to be such a low temperature that almost it would never happen. So the more salt concentration, the lower the freezing temperature of the water would be.
Okay, I'm just gonna skip all this because we just went through this, and the hypotheses which got proved correct was if the ocean does not freeze, then both two will not be frozen overnight, and it was proven correctly. Okay, so again, like Edward and Mabel said, the freezing point of water is 0 degrees Celsius or 32 degrees Fahrenheit. However, when salt is added to water, the freezing temperature drops. Ergo, the more salt in the water, the lower the freezing point. Okay, so as the rain erodes the rock, acid in the rainwater breaks down the rock. This creates ions which ultimately reach the ocean. Chloride and sodium are two ions that are prevalent, making up 90% of the salt ions in the ocean. Sodium and chloride, or salt, make up 35 per thousand, or 3.5% of salt water. Seawater, which may not seem like much, but if added together and out of the ocean, it adds up to 120 million tons, which is the equivalent to the height of a 40-story building. And yeah, that's the end. I was going through most of the PowerPoint as we went along, so that's why it's just 2 slides. But yeah, that's it.
We're the best.
What affects the temperature change? What affects the water not freezing? Sodium chloride.
Explain.
What do you mean?
What part of the you said that the ocean would not freeze as much as like the glaciers. What was the causing? What is the ratio between the ocean versus the glaciers?
The difference of temperatures?
Beside the temperatures, what else?
Miss, when the waves, as the waves keep crashing and moving, that prevents water from freezing. The glaciers stay still in one place. So
Okay, but also what else that will prevent it from freezing?
The sun rays.
Nope, beside that. Temperature, one of them. What else?
Well, there's more surface area also.
The surface area,
Yeah,
right?
that's
What
one of
else? What is in the glaciers versus the ocean that's different?
what is in the glaciers?
Yeah, the water, the
There's
water,
less salt.
the salt.
Yeah, he
The
said
salt,
that.
the
The
salt
concentration,
ions.
Yeah, there's less salt.
Okay. Which contact, what is the value that will affect it? The salt. What will affect the salt?
What will affect the salt? The temperature.
The temperature. Okay. All right. Okay. So the amount of salt in the
The
ocean
concentration.
and the concentration, the temperature,
surface area.
the surface
Yeah,
area.
because the salt breaks the water molecules. apart
Exactly, and the
water.
salt ions will break the
Okay,
water
yeah.
molecules. Okay. We're good.
Okay.
So wait for your judgments. Now, the poster, that person who is supposed to give me the poster is getting a 0 today.
Okay, you can stop subbing me, thank you.
I didn't put a
Don't
name.
put my grade out there, thank you.
Okay. Any more questions? No? Okay. Thank you for your.
Good job. This is the first time I ever had the opportunity to judge a science project. So I am very honored.
Sign out with your account.
Thank you guys for watching the AUO Science Fair. I'm logging out.